Okay. So everyone, good evening, everyone again. Yesterday we covered few more topics. So slowly, if you see like the direction that we are taking, we started with the concepts and then slowly we are moving to uh, making our code better. So we started with the concepts of what are identifiers, what are variables, and how we store data in temporary storage locations. Why do we need to store data? Ultimately, programs are all about manipulating the data. And programs, so we write instructions, we call statements, right? Those statements get executed, and in that process, data gets manipulated. We give certain input to the program, we get certain output. And so that's what programming is all about. So we saw that we started writing primitive programs where what is going on? Okay. So we had our initial code like this, a bunch of statements without any control. They just start executing from top to bottom. Then using the concept of decision making, if else loops, we brought some control. Okay, don't blindly execute. For example, this statement, right? This statement may or may not get executed. This block of statements, this group of statements may or may not get executed. Same way, this may or may not get executed. How will we know whether this one will be executed or this will be executed? Depending on the condition, right? So there's a condition which gets evaluated. The result of the condition evaluation will be true or false. If the result of the condition evaluation is true, one set of code will be executed. If it is false, the other set of code will be executed. Most of the times, this is how you will be building your logic, right? Even if you are doing, let's say, manual activity, you will, let's say you are supposed to configure some device in some way, right? So first you will check whether, let's say, the user has already been configured. If the user has already been configured, you will not do anything, right? So even in your real life, without this automation, without writing code also, you are indirectly using these things, conditional statements, if else statements, right? Just because you're asked to configure a router or a device, you will not blindly go and do everything, right? First, you will see whether something has already been there. If something is already there, you don't do it. What is missing, only that you do. So that is the concept of conditional statements. If we saw if else, if else, to take care of multiple conditions. Now we can try and apply this to our day-to-day networking concepts as well, right? Now we can build something like vendor is equal to Cisco, right? If vendor is equal to Cisco, right? Let's say the set of commands to be run is um, whatever is the other device specific device, and vendor specific. You see here I've put double equal to, right? This double equal to means that we are doing a comparison, right? Because single equal to is like assignment. Here itself it is there. Vendor is equal to Cisco. When I do this, vendor, there's a variable which gets created with this name vendor, and the value Cisco gets stored in this. So this we call this as assignment statement. But if you want to check whether vendor is having the value Cisco or something else, we should use comparison operator. This is known as comparison operator, which is double equal to. Okay. So that is about conditional statements. We can take more examples as we go forward. I'll give while giving the exercises for this, right? I'll be giving more examples. Now the next concept is loops, right? Now, concept of loops is something like this. We have router 1, router 2, router 3, right? So we are given a set of tasks saying, okay, connect to router or device, execute, show run, and from the output extract something. Right? So let's say we are asked to do this task. Now we need to do this task for router 1. We also need to do this for router 2. We need to do this for router 3 as well. Right? So for same task, you are doing again and again and again. Here there are 3 devices, so you'll be doing 3 times. Let's say I have n devices. I'll be doing the same set of tasks n times. Right? This concept precisely is known as looping. Right? If someone is going on saying the same thing again and again and again, we'll say he is going in a loop. Right? So that is the concept. So you have a set of instructions. You go on doing the same thing again and again and again. But then if you are going on doing the same thing again and again and again, where do we stop and how do we know when to stop? So there's a condition which is also involved. Here also we have a condition, right, which is involved. Now what is the condition in this case? First we need to check how many routers are there, right? Whether there are 3, whether there are 4, whether there are 5, whether there are 100. If 100 are there, do this 100 times. If 50 are there, do it 50 times. If 30 are there, do it 30 times. If only 1 is there, do it only once. So that is the condition. Checking how many are there. Okay. Now that is one type of condition. Second type of condition is as long as, right? As long as some condition is true, keep doing it, right? This is something like let's say we restart a device, we reboot a device, right? You keep pinging it to check, is it up, is it up, is it up, right? So that is the other condition. As long as the status of this is not what we are expecting, we keep doing something. So that is known as while loop. While device is not up, keep checking if it is up. The moment it is up, you stop checking. Right now that you know it is up. Is this clear? There are two types of loops. One is you have a number of devices. Whatever task you are supposed to do, you do for each of those devices, because it's not like, okay, for this router we will do something else, for this router we will do something else, right? All routers are same for us. So whatever I do with router 1, I'll be doing same thing for router 2, router 3, router 4, router n. In such cases, I'll use something called as for loop. This kind of loop is known as for loop. For router 1, do this, router 2, do this, router 3, do this, and so on. Or for first router, do this, second router, do this, third router, do this, nth router, do this. So that is one kind of loop known as for loop. The other loop is known as while loop, which is used in such situations, right? You are expecting something to happen, like a device to come up or a device to go down, right? You issued as a shutdown command, but it is taking some time for the device to shut down. It is like it is killing all the processes, etc., etc. So you can do something else only after it is completely shut down. So you need to keep on checking. Is it shut down yet? Is it completely shut down yet? Is it shut down yet? Once it is shut down, then you do something. So that kind of loop is known as while loop. Anyone, any questions here? So you have two types of loops, for loop and while loop. The while loop is something like you have a condition while some condition. Whenever we say that condition always evaluates to true or false. Right? You guys are with me on this. So let's say true. Now, the syntax is just similar to if. If condition colon, which indicates start of the block, and then statement. Same way, while condition colon, which indicates start of the block, and statements. Yeah. How many statements you want, you can put. Now, here I'm just showing a print statement, but when we go to the other examples, like when we start working with connecting to devices, etc., we'll see other significant this thing, or reading files and so on. Right? Now, this just like how in case of if condition, if these statements will execute only if this condition is true. Same way in case of while also, only if this condition is true, this statement is executed. Right? I'll show you the difference between if and while. Right? If true. Now, instead of specifying a condition which becomes true, I can simply say true also. Right? I can directly put the value true also, or I can say 5 less than 6. 5 less than 6 is true. So this condition evaluates to true. Hence, this will be printed. Right? So this is as good as what I just did. Right? I can directly say if true, then do this. Now, first I'm trying with something we already know. Later, I'll change it to while to see what is the difference. So first it comes here. If Condition is true, so it goes inside and prints it and stops. Now let me replace this if with while. While true, print this. Let's execute. It's going on and on and on and on and on until I forcefully terminate it using Control C. So that is the difference between if and while. If and while are almost same, except that if you use if, the condition will be checked and the statements will execute only once. Whereas while is a repetitive execution. Right? First it comes here, while condition is true, it prints this. Again it goes back because if is not a loop, while is a loop. Right? So again, after printing this, again it goes back to check the condition. Again it's true, it comes here and prints this. Again goes to check. Now I specified this as true, so this will remain true forever. That is what is happening here. Since that condition is true forever, this will keep printing. The statement will keep printing forever until you forcefully terminate. Right? So while writing while loops, you should take care to ensure that somehow you put a check for this condition to turn false, right? Which will be seen. So now let's say I want to print this statement 10 times. So I'll use a variable I is equal to 10. Right? Or I is equal to 1 starting point. While I less than 10, okay. I chose an initial number, and then I'm saying, yeah, while I is less than 10.
What is F? It's float?
No, this is known as formatted string, right? If I want to put variables into my string, right? So I'll put an F here, which says that yes, interpret this wherever you see this kind of thing, replace this with this I with the value of this variable. The other way to write it is dot format. Right. So this says that okay, format this string by, so this empty brackets are like placeholders. Placeholders for what? For this variable. Whatever the value of this variable will be substituted here when the string is being printed. A short form for this is this. Directly I put the variable now here. And I don't need to call this format. Okay. Let me execute this. What will happen now? One thing that you can do initially when you are doing programming, right? Write the code and do not immediately execute it. First, you mentally execute the code and see, okay, what happens when I execute this code? I've created a variable I is equal to 1. Then I'm checking for a condition I less than or equal to true. Obviously, 1 is less than or equal to 10. So this condition will evaluate to true. Then this statement will be printed. Then the value of I is not changing. I will always remain 1. And 1 is always 10, less than 10. So this will keep executing. So this is as good as my previous statement, which ran into something we call it as infinite loop, right? This kind of thing, which will never terminate. We call it as infinite loop, right? So whatever I've written now also is kind of going to result in the same thing. So we need to have a termination condition. whenever you write a while loop, we should ensure that we write a termination condition, which will ensure that the loop terminates. When should it terminate? Whenever our objective is satisfied, achieved, right? Now here, I want to print this 10 times. So that's the reason I said, while I is less than 10, do this. Now I should increment I should increase I. First iteration, I is 1, right? Then I print this. Then what I should do? I should increment I by adding 1 to it, right? So first, initially I is 1 is less than 10. This is printed. Then it comes here. Plus 1. 1 gets added to I. So I becomes 2. Then it goes here. 2 is less than 10. This is printed. Then I becomes 3. It goes here. 3 is less than 10. This gets printed. So like this, it goes on and on and on till for 9 times, right? For the 10th time, I becomes 10. Then for the 11th time, I becomes 11. Then here, or 10, I is equal to 10. Here it comes 10 is 10 less than 10? No, right? So this condition becomes false after 10 times. And then it won't go inside. Once this condition becomes false, it won't go inside. This loop will terminate. Okay. So this kind of statement is very important when you are writing while loop, because this is the condition which we are checking. So somehow we should ensure that after our required number of times the loop executes, somehow we should make this condition false. Otherwise, as long as this condition stays true, our code will keep getting executed.
So Ravi, one question. So why have you put that I equal to I plus 1 after while? Can we try to do it before,
We can do that. We can do that. Why I put that is because I'm printing the value of I. So before printing, if I increment the value, it will start printing with 2. Right here, I said 1 to 9. I'm in iteration 1, iteration all the way up to iteration 9. Here it starts with 2. That's the reason I put increment statement after my print statement.
No, I was asking if we can put that statement before while.
If you put this statement before while, what will happen?
Yeah, it continues running like before.
Yes. Because initially I is 1, then I became 2. 2 will always remain less than 10. You are not changing the value inside the loop. Unless you change the value of this variable inside the loop, your condition will not become false after a certain number of times. Right? That's why this statement has to be inside the loop.
Okay.
Okay. So this is a kind of schematic diagram. Where is my loop diagram? Yeah. Condition. As long as the condition is true, go on doing this. Evaluate the condition. If it's true, come here, execute it. Again, go back. Evaluate the condition. If it is true, come here, execute the code. Again, go back. Evaluate the condition. If it is false, stop. Okay. So some examples like here I have hard coded the value as 10. Right? Instead, I can ask the user to input some number. I replace this 10 with num. And this I'll put less than or equal to. so that it runs exactly for 10 iterations. Here it will ask me if I say 5, it will run for 5. If I say 7, it will run for 7 times. If I say 10, it will run for 10 times. Okay, so all I'm doing is printing here. I can also do something like finding the sum of numbers, that kind of stuff. Right? I is 1. I mean, this is something like finding the number of sum of the numbers. Like if I enter 5, right? Find the sum of numbers up to 5. 1 plus 2 plus 3 plus 4 plus 5. So initially my sum will be 0 because I'm starting initially. Then my starting point is 1. So I'll add that 1 to this sum plus I. In the second iteration, then my increment condition is there. I becomes 2. My sum is 1 now. That sum plus I again. Right. Initially sum is equal to 0, I is equal to 1. So my is equal to 0 plus 1, which is 1. Now sum is 1, I is 2. So sum becomes 1 plus 2, which is 3.
It seems kind of Fibonacci series.
Yeah, Fibonacci series is somewhat different. There you
Yeah,
have,
that's a different. It start to
Yeah.
0, 1, 1.
So in all such solving such problems, right? Whenever we have problems involving numbers, we use while loop. Okay. Now inside my while loop, my sum is getting calculated. By the time it reaches outside, my sum is ready, so I can just take. Okay. Now, where this could be useful in networking is probably the example which I said, like you are waiting for the device to come up or go down, or you're waiting for the state of the device to change based on some condition. In such cases, you can use while, right? While router is down, right? So you'll have some condition which will check how which knows how to check if the router is down. And let's say the ping output, right? But as long as your ping output is like not as you expect, then you keep waiting. Then once the state changes and ping output starts coming as you expected, then you go ahead and do some other stuff. So that is one example I can think of, and if I come across any other examples, I'll put them in exercise. Now, this will make sense for people who are familiar with other programming languages, because in other programming languages, there's no concept of else statement with while, whereas Python supports else statement with while. Right? For you, this concept is new, so it's as good as like new. So just like how you have if else, you can have while else. Right? Only thing is I mean, basically it's the same. So else. So after, as long as this condition is true, this keeps going in loop. So it stays in while. Once this condition becomes false, it comes into else. And it says, yes, whatever we put inside that gets executed. So it's just so I put the statement as in else. So first this gets printed, then this gets printed. So after 4 times, this condition becomes false. So instead of it won't go inside, it comes here, prints this statement, and finally it comes out to the main block and prints this statement. Okay, you can try it out probably later. Okay, the next is for loop. This is very, very, very useful because most of the times, like I told you that lists are very, very useful and very versatile data structure, right? So whenever you are working with lists, right, the elements of the list are all the same to you. It's not like, yeah, the first element of the list is your favorite element and the last one is not favorite element, right? You don't know what is first, what is last. So you have to treat the entire list as it is. So whatever you do with one, you have to do with all others. In which case, for loop comes to your rescue. Whatever, so instead of doing it again and again and again using multiple duplicated code, you use for loop. Okay. So for loop structure is something like item from sequence. Now the sequence is list, right? So item is like first item. It starts from the beginning of the sequence. It takes the first item, does something, then goes here, takes the second item, does something, goes here, takes the third item, does something. So this goes on as long as there are elements left in that sequence. Once your list is exhausted, it detects that yes, there is no next item, it goes out, right? If no more items are in the sequence, it goes out and your loop gets terminated. Okay, so for this, we'll take the, anyone has done that exercise, which I gave on first day?
I tried doing it.
Okay, we'll take that. I think it's already here. Yeah. So you see, I have 3 strings, right? Interface 1, like this is kind of extracted from this kind of running config of some device. So I gave this string, and this string. So those are these 3 strings, right? So first task is to split this and extract IP addresses. Right? So this block of statement will do that for interface 1. Right? So I'm creating a temporary variable and taking this interface 1 string, and then, okay, let's do it together. Let's take this values. This is my input. So what is my first task? First, I have to split this so that I can get, now there is this text and IP addresses. So first I have to split this. This is string, right? First I have to split this string so that I get a list. From that list, I can ignore these and pick these up. So first I have to do this for, let's say, this guy. So I'll create a temporary variable because I get a list. So this is my string. I'll say dot split. Now inside split, I can either specify this split by space because we want to take this, and this separately, right? So I can specify this. Whenever you are using split, you can specify which character, by which character you want to split. Now, space is like default character, which will be used for splitting. So I can as well omit it. If I simply say split, it will split the string by space. Okay. So this statement will split the string. So let's print out how does this guy look. Okay, this is how it looks. My first string has been split and I got this. Now from this, third and fourth elements are your IP address and subnet mask, right? So I can create another list, another temporary list. fs1 underscore, what did I call them? IPs. So first I have to create a blank list, right? So that I can extract these values and push it into my blank list. Which function I can use? Append function. Dot append. What to append? This guy's second item, 0, 1, 2, and 3. And the third element. Second and third elements are like, since I'm starting with 0, third and fourth elements. Now this is a list which contains the IP addresses. So far you guys are with me? I have split this string, extracted this, and appended to another blank list. So I got my list with these. Now the same thing I need to repeat for interface 2 and interface 3. Right? So one way was how I have done here is I repeated the same code for just by replacing interface 1 with interface 2. I've copied this and placed this. Wherever interface 1 is there, I simply replace with interface 2. The second string, this guy. Another thing that you'll be doing when you're writing a lot of code, right? You'll be copying and pasting, right? Be extremely careful when you're copying and pasting to properly edit and ensure that, yes, after copying and pasting, you made the necessary modifications. Otherwise, you will end up like somewhere I had left this 1. Right? I'll keep wondering why my additional IP address is going and getting appended to interface 1. That's another pitfall that we usually come across. And so I have extracted and somehow got the lists for first 2 interfaces. So you see there is a repetition of code. The same code is getting repeated for this. Is there a better way? Yes, for loop is our answer, right? So somehow I can use for loop. Now for me to use for loop, first these strings have to be in a list. right? So first I have to put them in a list. Anyway, that I'll be showing you how to. Okay, first let me complete this exercise for one, then I. No, for we need others also, right? Yeah, now I have one interface 1 IPs and interface 2 IPs. My next task was to merge them, right? Which I can do. Which I can do using interface 1 IPs dot extend. Like these interface 1 IPs dot is it extend? Yes, it is extend. Okay, first I have to create that. It does not exist. No. Sorry. I should be appending them, extending this guy. Oh, this also should work, right? I'm taking this guy and I'm extending it with this guy and then putting into a third variable. This does not return anything. I can simply take this. Right? I can take this. Dot using this. I can take this. Now, if I'm extending this, all that stuff go and sit inside this. So instead of doing that, I'm creating a blank code guy and extending that with first and second guys. Okay. Now from this, if any duplicates were there, I've asked you to eliminate it. Right. Before that, to easily identify duplicates, we can sort them. Right. We can sort this list. They get sorted. Basically, these are strings, right? Though they are strings, the strings are compared using something called as lexical comparison. Lexical means the order in which they are occurring in the alphabetical order, right? So A is less than B, B is less than C, and so on. Same way, 1, though it is a string, we are writing it as a string, 1 becomes less than 2. So in that sense, 10.1 is less than 100, right? It compares first value by first value. 1 is same in both the cases. 0 is also same in both the cases. But here it stopped with 10, here it is 100. So it compares, okay, 10 is less than 100. That's why this is the first element, this is the second element. Same way here, 255, 255, 255, 255. Till third octet, it is same. Here it is 252, here it is 255. That's why this is placed before 255. So that's how this gets sorted. Now, in this, there are no duplicates, but if duplicates are there, we can find its index and do del IPs of whatever is that index. If there is a duplicate, right? So we could delete so that we can get a unique list. Which is what I'm doing here. And then printing IP addresses separately and subnet mask separately. So that's where I'm using the slice operator. Right? Up to third position, there are IP addresses. From third position onwards till the end of the list, there are subnet masks. So that's how I have achieved this. But this is okay as a version 1 code. But
Ravi, where in the code have you compared the IPs? Because you have specifically mentioned to delete IPs 3.
That's what I mean. In this case, at this point, we do not have if condition. We have not discussed if. There is no mechanism to compare. So my assumption was, okay, you will look at them and then delete it. Okay. So that's what we'll be improvising this by introducing concept of loops, conditionals. We'll be comparing and then improvising. That is version 2. Since we know if, else, and loops now. Okay, that was version 1. So I'll rename it as 1. So in this, I'll create an array. Now, right, so I have a list. Right? As I said, the best way you can traverse a list is using for loop. Right? Now, there are two ways you can traverse a list using a for loop. One is either you can find its length, right? You can find the length of, okay, first let's take a simple list. Find devices. Okay. Now, first we can get a length of this using. There's a function called as len of list. This is a list. Len of list will give me length. If you see, I mean, I'm taking pain to name my variables too, so that it suggests what am I storing, right? Instead of simply picking values like A, B, C, X, Y, Z. So I get 5. Now, I know that I need to traverse this loop 5 times because there are 5 elements, right? So there is something called as a range in Python. Range is like, as the name suggests, the range. What is the some object which will contain these many 5 elements. So I'm saying, okay, create a range of 5. This is how it looks: 0 to 5. Starting with 0 does not include 5. Now I can say for some temporary index, right? Now this range is like 0 to 5. So I can choose temporary index for I in range 1. Print I. And I have not yet traversed my list. First, I am traversing range to understand how range looks. And this is how range looks: 0 to 0, 1, 2, 3, 4, 5. Right? So looks like now these 0 to 4 are precisely my list indices, right? Since I have 5 elements in this is at position 0, this is at position 1, 2, 3, and 4. So if I want to traverse a list of size 5, I can use a range of 5. Here I'm creating with a hard-coded number. Instead of this, I'll use my length property.
So Ravi, how did this I came in picture? You have not defined it anywhere.
I is like a temporary variable.
Okay.
So I'm saying, okay, assume that it's like a counter. Right? For this counter, start counting this range, and the first number that you count, put in this. Then second for the second iteration, put the second value in this. So this is like a temporary variable which we use for traversing the list.
Okay, but it doesn't work with any other letters. So is it just?
It can be anything. It can be anything.
I just tried with A. It didn't work for me. With I, it is working.
No, nothing like that.
Oh, okay, no worries. Yeah, I didn't
Yeah.
change it. Mhm.
Yeah, you need to change at both the places. Okay. So what I'm trying to say is there are 2 ways you can traverse a list. One, by finding its length and then creating a range, right? What is the length of this list? I can find out using length function, len function. Len of this list will give me length. Now I'll use this length to create a range. Now this range of this list length will exactly give me my range, which matches with the indexes of the list. Then I can simply say for index idx in range print. How do you access list elements using index mechanism? Interfaces of index. Right? Now we saw that this index for loop is going from 0 all the way up to 4. So for the first iteration, this will be interfaces of 0. For the next iteration, interfaces of 1. For the third iteration, interfaces of 2, all the way up to 4. Now what I am getting here are elements of the list. Okay, so to avoid confusion, let's use this list now. Okay, I have my
What you
interfaces.
can also do, like you can print element, okay, and then the number in that element or value in that element. Is it?
I'm coming to that. I'm coming to that. Okay. Okay. My elements get. Right. So this is one way of extracting elements in a list. Now there's a simpler way. Simpler way, without finding its length, without creating a range, without doing all of this. There's a simpler way. Right. Let's comment this out. But there will be some situations where you have to use this index based accessing. So where you have to create a range and then use it. So that's why I've shown you both the ways. Now another simpler way is, I know that there's a list of interfaces, right? So I'll simply say for something. This can be anything again, X or Y or Z in interfaces. Right? For X in interfaces, print X. Right? Now I'm saying for something in interfaces. This interfaces is a list. So for this, so this will be initially it will be the first value. For the next iteration, it will be second value. For the third iteration, it will be third value, and so on. Okay. So this is like again our temporary variable. So I can call it as I. Instead of that, what we do is like now this is interfaces. So I can say for interface, single interface in interfaces. This is a normal convention that we normally use. Like let's say I have a list of devices. So while writing a for loop, I'll write for device in devices, do something with the device. Let's say I have the list of routers. For router in routers, do something with that router. So that's a normal convention. I can use anything for that matter, but this makes more sense. For interface in interfaces, print each interface. Because I'll be going in a loop doing one thing at a time. Okay, this is pretty neat. But now the problem is you do not have the index, right? They are getting printed 1, 2, 3. But in case you want to know whether which is first one, which is second one, which is third one, you do not have a way to know. Whereas here you have that index still available with you. So that's the only difference. But for all practical purposes, this is better if you don't need the index. Now, whatever you do with one interface, you can do with the same with other interfaces. Right? What is it that we'll be doing? Splitting. And we have C, the score 10 is equal to interface dot split. Right? So first time that will be split. Second one will be split in an iteration. But we also need to do that iteration thing. So we need NTFC. Let's go like this. It's a blank array. So first time I take this guy, split it. I'll take its second and third elements, and I'll have to push it into this. I'll do that here itself in the loop. Dot append of to and outside the print this guy. So you see, I have written code only once, but this code will be executed for this, this, and this. And your interface IPs which you have created here will get populated with all these IP addresses. Sorry, it gets, yes, it gets appended with all the values. Right? This, and this. So that is the power of for loop, right? So just with one set of statements using loop, we achieved whatever we have done there using so many statements. After this,
this element 2 and 3,
Mhm.
it's different, right? Where it's come from, like 2 and 3.
Yeah,
Okay, got it. IP
yeah.
is 1, 0,
Yeah,
address
yeah.
is 1, then
0,
2
1,
and 3.
2,
Okay,
and
got
3.
it.
I know this is not a very foolproof way here because if the string structure changes, these indices will change. But we'll solve that problem when we come to that.
no, I still didn't understand. Like, I'm getting the output, but how it is working? Like, how did I get
Okay.
those values?
Let me show you by taking this. Okay, this is a string. Let me do this without loop for one. Right?
Okay.
So,
For one, I can understand, okay, you are taking the second one, so 0, 1, 2, so it will be 10.1.255.11. But the third one also came, but I'm also getting the output for the fourth IP, the last one, the third one.
yeah, because I'm going in a loop, right?
Okay.
So now, first time this interface becomes this string, right?
Mhm.
That gets split. This string gets split first time.
Mhm.
Then 2 and 3 will be this and this.
Okay, understood. Yeah.
These two will get pushed into this.
Yes, I got it now.
Yeah, for the second iteration, these two will be pushed. For the third iteration, these two will be pushed.
Thank you.
Okay. So our first task is done. Now from this, we have to sort. Right. We will sort it. Sort. I mean, if you are doing this, what do we call? We don't really need to sort because if you are writing code to avoid duplicates, but just for visual purposes, we can sort to see if there are any duplicates. Okay, this guy is duplicated, right? So now how do we eliminate this duplicate? Obviously, we cannot say, okay, 1, 2, 3, fourth element is the one to be deleted. We cannot do that, right?
So are you saying if I'll sort it and anything found duplicated would get deleted?
No. It will not be deleted. I just sorted to arrange them in this IP addresses followed by your these things. And for sorting, we need to use little bit of more logic. Right? What we can do is we can create a unique IPs, a list like unique underscore IPs variable, a blank list. Right? Then I'll write a if loop. This is my list of all the IPs, right? So what I'll do for IP in this loop. So what am I doing? I'm going on loop. I'm going on this in a loop. I'm taking each one. First I'll take this, then 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 I'll take this, and do something. What is that something? Now I have a blank list, right? Each IP I will push into this blank list or this list only if it is not already present in that. Whether it's already present in that or not, we can check using. There is an operator which will help us to check whether an element is already present in something or not. In and not in operators are there. Right? Yesterday we discussed in and not in operators are there. So using that, I will check if this IP is already present in this or not. I know initially it won't be present because this is blank, but when I go on adding elements, maybe some elements will already be present. So when I do, first I will check membership. And if it is not already present in that, then only I'll push it, which I can do using if IP not in which one? Unique IPs. Then only what I'll do, I will unique IPs not append IP. Okay. The simple trick will so how will it work is first this will come, right? First this guy will come. Now currently this list is blank.
Ravi, I have a question. Why my sort function is not working directly?
Sort function is not working.
Directly, like this is a feature of sort function, right? If I have a few IP address or strings in the list, then it's a sort function responsibility to put them in order, right?
Yes.
So why it's no, because I have a list, right? This interface.ips you see on the top, python exercise.py, it should sort that IP address. And subnet mask.
So this is without sorting, then I'm sorting, then this is with sorting. This is without sorting. This is with sorting. Working, right? Yours is not working. Maybe you can check where exactly you have placed the sort and then got disconnected. Okay. Meanwhile, when he's coming online. Okay. So this simple trick will help me to do this. Right? How this will work is, right? Initially, this is a blank list. So here I have a blank list. Then my job is to push all this into a new array, ensuring that duplicates are not coming in. So first I'll take this. My list is already is blank, so there is nothing. So I'll put it. Then second element will come. It's not already inside, so this will be put. Then third element will come, which is not already in, it will be put. Then fourth element will come. It's not already in, this will be put, then fifth element will come. But this guy is already there, right? This guy is already present in the list. So this not in will return false. This not in will return false. So it will not go inside. This will not be executed for the fifth element. Then sixth element will be inserted, which is 255. So we'll end up with unique list of IPs. Okay, that's this. Of course, it's not sorted, so that's why we are doing like this. Sort does not return anything. That's why it is coming as 1. Okay. Now, what's your next task? You have to return these separately and these separately. So we can make use of another function, right? We know that subnet mask will start with 255. So we can make use of a string function called as starts with. How will you know whether that is there? In Python, you just think aloud. Okay, now I need to check whether the string starts with something or not. Then you check Python documentation, 99.9%, there'll be a function which will help you to do that, to find out whether a string starts with something or not. If you still want to ensure that it is there, go to Python interpreter, where str. Right? Starts with is there. This guy dot starts with of 255 will return true. So if your IP address is starting with 255, you can push it into one array called masks. If not, you leave it, you push it into another array called IPs. Okay, of course, I'm creating so many temporary lists, but that is fine. IPs, blank list, masks, blank list. Now I have to start traversing this. So I need to check each IP address in this unique IPs. How will I do that? Again, using for loop. For IP in unique IPs. If IP dot starts with 255, then what do? You push this IP into masks. Mask dot append IP. Else, if it is not, then push this IP into IPs. Okay. Print these in masks.
See, in else condition also you put IP, and that condition also you put IP.
It's the same IP that you are dealing with, right? It's the
So you
same IP.
should be masked, no? Like append IP. Okay, got it.
Yeah. Whatever you do for this IP, only in each time, either if will execute or else will execute. Both will not execute at the same time. Okay. So that is your for loop. Anyone, any questions? I'll be sharing this code so you can go through each line and convince yourself how it is working. I'll also share the one without this thing, the crude way of doing it, and then proper way of doing it. High level approach is, yes, I put all these strings into an array. Then I'm traversing this array of strings. So let me call it as interface underscore strings, strs. It's interface string. And for interface string, in interface strings, split it, extract second and third, push it into interface IPs array. Now from this you want to avoid duplicates, traverse that array using for loop, create another blank list called unique IPs, keep traversing and keep pushing those IPs into this by just checking a condition. Just before pushing, you check whether if it is already there in that list. If it is already there, don't push it. If it's not already there, then only push it. So that's a simple technique to avoid duplicates. Enough for today. Okay. Okay, so that's how you can create a unique. Now from this, let's say we want to split it in based again on some condition. So again, we need to traverse that and apply that condition and accordingly take some action, what you want to do. Since we want to split that into two separate lists, we created two separate blank lists and we are checking that condition, whether it is starting with something or not. And then accordingly, we are pushing it into that. Yeah, sure, I'll be sharing that. Okay. We still have time, so shall we stop or continue? Or is it too much?
Not too much, but Promit is not there, and
Okay,
Ramesh is also requesting.
Okay, sure. Oh, he also got disconnected.
Yeah.
Okay.
Yeah, and it's a lot to practice. We'll have to Google for exercises and practice these things.
Okay. You can ask me, okay, give me this exercise or that exercise, so I'll try to pull out if I already have something.
Yeah, please do. If you have any exercises for the decision making and these loops, it will be helpful.
Okay. So I have one classic, this thing, the discount calculation. So you can try that.
Okay.
I can add more twists and turns. So problem is something like, yeah, first, depending on the bill amount. If bill amount is below something, then discount is this much. Then if it is above something, then discount. Then we can add membership, right? Let's say if it's like Apollo Pharmacy or MedPlus Pharmacy. If you have a membership card, you get additional discount, right? Then like senior citizens, if you need to take in his age. If he's a senior citizen, then you get additional discount or some complimentary stuff like, okay, your medicines will be delivered to home, something like that. So you can mix all these things and it becomes a nice if else.
That way, I think that will be too complex for us right now. But yeah, share that. And apart from that, if you can, share some basic exercise as well, that will
Sure,
be
sure. Yeah. That's what it will be like step by step, how I have given. So you can do step 1 and then try to extend to step 2 and like that, gradually increasing the complexity.
okay.
Yeah. Okay. So I'll be sharing the new code that we have written and I'll be sharing sample exercises.